Hello and welcome to the Edupedia World. In this tutorial, we'll see about collection set and we'll study the part 2 of this video. Since in previous video we have theoretically studied some of the methods in set interface, now we'll be trying them and also we'll be looking at the implementation of set interface. So let's begin. Okay guys, now let's see the set interface. So our set interface is defined in java.util package and it is defined according to a generified type which is E. The parameter it contains is E, which is type of element maintained by set, and it could be anything like integer, string, boolean, so or any your user defined class, anything. Okay. Then all the super interfaces of set are collection, iterable. Then we have sub interfaces, which is navigable set, sorted set, and then all the implementing classes are abstract set, concurrent skip list set, copy on write array set, enum set, hash set, job state reason and linked hash set, and tree set. Out of these, the important classes are linked hash set, tree set, hash set. Okay, so these are the things that I think you should know the implementation. Fine. For rest of them, you might skip as of now and might cover whenever you think you have time. But out of these, the important are linked hash set, reset, and hash set that you should at least know. Okay, guys, so these are like the methods that are present in the set interface. So on the left hand side are the method description. On the right hand side, we have modifier and type. So first is add. So now this add the specified element to this set. And if it is not already present, then it does add and it returns boolean if it is added successfully. After that we have add all. So add all adds all the element in a specified collection to its set if they are not already present. Again it returns a boolean. Then we have clear. So clear is like void clear. It removes all the element from the set, and optional operation obviously. Then we have boolean contains, it returns true if the set contains the specified element. Fine. Then we have contains all, which return true if the set contains all the element of a specified collection. Fine. Then we have equals method, which compares the specified object with this set of equality. So it will tell whether two sets are equal or not. Similarly, we have hash code, which is again taken from the object class. It returns the hash code value for this set. Then we have is empty, which returns true if the set contains no element. Then iterator returns an iterator over the element in this set. Okay guys, so these are the some of the methods. Some more methods are is empty, it returns true if the set contains no element. Then we have iterator, which returns an iterator over the element in this set. So that means you can iterate it over, you can traverse through all the elements using an iterator method. Then we have remove object. So now it will remove a specified element from the set if it is present. So if it is present means if it is not present, then definitely, it might give some other results. But if it is present, then it will remove it and will return true as a part of boolean. Then we have remove all. It removes all from the set all the elements that are contained in the specified collection. Fine. Then we have retain all. So it retains only the element in the set that are contained in a specified collection. Fine. After that we have size. Now size returns the number of elements in this set. Okay, it is give you an integer value. Then we have to array, which returns an array containing all the element in the set. So it just converts your set to array, this method. Okay, and it will return your object array. Then again we have to array, which take a parameter which is taking again an array of a particular type for which you have defined your set. And it does returns the array containing all the element in this set. The runtime of the returned array is that of a specified array. So you can define, what will be the runtime of this array by specifying what's T. Okay. Now that was about the set interface. Now let's see the hash set. Okay. So now your hash set is again a public class which extends the abstract set, and it does implement set interface, clonable and serializable. Fine. Your hash set contains specific constructors. So the first constructor it contains is a default constructor, which is an empty constructor. So it's create an empty set, and the set is backed up by hash map, which is having a default capacity of 16 and the load factor is 0.75. Now what do you mean by load factor? Well, if I say load factor, that means then it has to increase its initial capacity whenever the 75% of its capacity get full. So load factor 0.75 means whenever the 75% of the set is full, it will increase its initial capacity. Up till then, it will keep the initial capacity as 16 only. Okay, so that's the purpose of load factor. Now there is another constructor which is taking collections. So this constructor will construct your hash set containing all the elements that is specified in the collection that you are passing as a parameter. Fine. Now you see that this collection can be of any type, which actually either of a same type E or something that extends E. Fine. After that, we have a third constructor which is taking int initial capacity. So it constructs an empty set, and the backing hashmap instance has a specified initial capacity and a default load factor 0.75. So you can define your own initial capacity to that particular hash set. Then again we are having a constructor of hash set which is taking initial capacity as well as the float load factor. So now this will construct an empty set backing up by a hash map instance which is having a specified initial capacity and also a specified load factor. So you can define your own initial capacity and your own load factor. Suppose I want to define initial capacity as 10 and load factor as 0.50. So as soon as my 50% is completed, my initial capacity should increase. Okay, so I can do that also. Now these are some of the method inside your hash set. So obviously it does include all the method that set interface is having. Additionally, it is having these methods. So it's having a add method which adds the specified element to its to this set, and if it is not already present, then we have a clear method which removes all the elements from this set. Then we have a clone method. Now this clone method is also taken from the object class. It returns a shallow copy of HashSet instance and the elements themselves are not cloned. Then we have contains. So now the contains, object O returns true if this set contains a specified element. Fine. Then we have is empty, which returns true if the set contains no element. Fine, then we have iterator. It returns a iterator over the element in this set. Fine. After that, we are having boolean remove object O, which removes the specified element from the set if it is present. Okay. After that, we are having a size method. So it returns the number of element in this set and it gives a integer value. So this was about your hash set. Okay. There is another important implementation of set class which is TreeSet. Okay. Well, there is also linked HashSet, but linked HashSet I think you can go through. It's easily available on internet. I mean, all of them are available, but since linked hash map is very similar to hash map, only its internal implementation differ. That's why I'm not keeping it as a separate portion in this tutorial. Fine, but definitely we'll do something, some examples either. Then we are having a TreeSet. So TreeSet is also a public class TreeSet which also extends your abstract set and implement navigable set, clonable, serializable. So you see it does not implement a set, it rather implement navigable set because navigable set actually, which is the interface that extends HashSet interface. Okay. Now, so you see most of the constructor and most of the methods are similar to what we have seen in HashSet and set. So the two another important methods that we want to discuss for TreeSet particularly is compare and equals. So int compare TO1 and TO2. So it does, compares two arguments for its order. So, whenever, because TreeSet actually do keep your order. So it does keep them either in ascending, descending, some order. Okay, sorting order. So how does it decide the order? It decides using compare method. So when you actually write your compare method or you override your compare method, so you have to implement comparable interface so that you can actually override compare method. There is also a compare to method. So yeah, the compare to method is actually available in comparable interface. So whenever you are implementing comparable interface, you override the compare to method. And if you are actually implementing comparator interface, then you override the compare method. So both of the method has a slight difference. It's just that the compare method can actually compare the two objects on basis of different parameters, whereas compare to can just compare on single comparison parameter. Fine. Then the other method which we are having is boolean equals object. Now this method is overridden method from the your object class, and it indicates whether some other object is equal to this comparator. Okay, so this checks for the equality for comparison purpose only. So this was about the tree set. Okay, so I'm going to open my Eclipse Studio, and then let's try something. So now let me just do a HashSet demo. So you will see I'm creating a simple hash set. I can even use a set, as a reference if you want to, or you can directly use as hash set. I'm going to make it, generified to take string. Now let me try to print this. Okay. So if I just want to print it, I can either use a iterator, so it will return me an iterator. So let's do iterator this time. Has next to check if this iterator is having a next element, and then I can go out printing the elements which I want to do by calling next on iterator. So if I do that, and if I just run this program, and let's see like what is the output this program will show us. So you see in the console it's only showing me 1, 2 and 3, whereas the number of elements I added are 5. But since 1 and 3 are repeating themselves, that's why it is not showing 1 and 3. It's just showing 1, 2 and 3 one time. That's because set cannot contain duplicate elements. Okay. Now let's try some more methods. So now I have to first of all import java.util, and then I have to create a class employee. So let me create a class employee over here itself. Ideally, I should have created in another file, but since it's an individual example, therefore I'm just doing it over here. So you see employee class is created. Now let me add employee ID to it and employee name and probably long salary. Fine. Now let's see. Let me try to create getters and setters and try to do it as we should do. Like we should have a getters and setters and all the methods as private so that it cannot be easily accessible outside this class to promote data encapsulation, data hiding features. So it's created. Let me also create a constructor, because whenever if I try to create an employee object, I do not want to individually call getters and setters every time. So let me just try creating a constructor for it. So you see, I have actually created the constructor for it and it's done. Now let me, add the object in the tree set that I have created above. I mean, usually we create collection when we have, large number of data. It might, we need to have like really a good number of data, then we actually use this collection. Um, okay, I'm just keeping it simple. I'm just changing the first word. So you see, I have kept the name by just changing the first word, and I change a salary a bit. I'll make 10,000, then I'll make 30,000, and then I'll make 40,000. Okay. Now let me add this to TreeSet. Add E1. Okay. So I've added my first employee. Now let me add all other, I mean the E2, E3, and E4 also. So you see, I've actually added all the 4 employees. Now let me just try to what should I say? Traverse through the list and see what will happen if I just traverse through the list. Okay. So for that, let me try to use for each loop this time. You can use anything, a iterator or a for each loop as per what you want. Both will work over here. Now you can actually print e dot get employee ID. Fine. And then I also want to print employee name and salary. Okay, just to make it stand out, I'm just putting a separate kind of line. Now let's run this. Oh, so you see, it has got some exception. What exception that it has got? Let's view that because it's really important to understand this. So you see, it's saying exception in thread main, class cast exception, src.com.collection employee cannot be casted to java.lang.comparable. Java.util.treemap compare. Okay, so you see it's giving a exception where it's saying that this employee class cannot be casted to comparable and the problem is coming in the compare method. Okay, so we have already seen that the implementation of tree map, we'll just see it again. I'm sorry, the tree set. You can see that it actually uses navigable set and navigable set uses sorted set. Okay, so I'm just, going to open the sorted set interface. Okay, guys, so in sorted set, just, read these lines. So it says a set that further provides total ordering in its element. The elements are ordered using a natural ordering or by comparator typically provided at sorted set creation time. The sorted set will traverse the set in ascending order and several additional operations can be provided to take the advantage of sorting. Now reading it from here, all elements inserted in sorted set must implement comparable interface. So you see that all the elements inserted in sorted set must implement comparable interface. So whether you are making a sorted set of a string or you are making a sorted set of an integer or your own individual class like in our case employee, it should implement comparable. Why so? Because it has to maintain the ordering. If it does not, then how will it get to know like in which order it need to maintain it? Okay, because in our case, employee, how will the tree set which actually in a way actually extends your or I would say implement your sorted set by going through a navigable set. So how will it get to know that how it need to compare? For that reason, our class employee need to actually implement a comparable interface. And thus, since it's implementing comparable interface, it's need to actually override the compare to method. So it can furthermore, it can actually use a comparator or a comparable. So if it is using comparable comparator, then it will go for compare. If it is using comparable, it will go for compare to. Okay. So otherwise, it will throw class cast exception, as had happened in our case. So you can see it's throwing up, basically a class cast exception, saying that it cannot be casted to java.rank.comparable, and it is giving a exception in compare. So let's try to actually implement comparable this time and see what difference does it make. So in employee, let me implement comparable. So since I have implemented employee, so this is giving me an error to implement the method, unimplemented method that I should have. So here is the compare to method. So in compare to, you have to define how you want the elements to be compared with each other. Okay, so I actually wanted that, my compare to method should take a employee instead of object. So for that, let me change over here to employee. Let me make it generified. So if I do that, then I need to actually change object to employee. So it will do automatically that thing for me. So if I again, remove and implement that method again, this time it will actually take a employee as a your object. So see, it's taking employee. Also, what I can actually do is I can actually compare, like if let's say I want to compare it with salary, I want to sort it by salary. So if salary is greater than O dot get salary, okay, then return 1, okay, else if salary is less than O dot salary, or I would rather do get salary. Although I'm like I can do salary because I'm using within a class, but I want to use getters, so it will return -1, else return 0. So I remove this additional return 0 from here, and let's run this time. Okay, so if I just try to run it this time, and if I want to, just check it out, what's the output that it's having. Okay, I think it's somewhere gone or got hidden. Let me just bring it back. Okay, yeah, so let me rerun it. So you see, it has actually printed something for us, and what it has printed is all the elements that we have inserted on basis of salary. So it has actually printed in a descending order because the logic we have used is to print it in a descending order. So first of all, the least salary, that is Neera, then Shira. After that, there's Neera with 30,000 and Ohra with 40,000. So this is how it actually printed our objects of employee class. Okay, so I hope so that you got it. So this is a way we can do it by using a what should I say, comparable, and even you can use comparator. For comparator, you have to create a class. Like if you want to do different comparison, if you want to do salary comparison, or if you want to do or your employee name comparison, then you can create a class like employee compare, then salary compare, and then you can implement comparator, and over there you can actually override compare method to do the different comparison. And while creating your tree set, depending upon how you want to sort the elements in this tree set, you can actually use a constructor of tree set where it could take your comparator object. So you can see there is a constructor, this one, which is taking a comparator object. So you can pass that comparator object depending upon how you want to sort it. Okay, so this is how you can do it using comparator object. Fine, guys. So we have done two important implementation of set. One is hash set and other is tree set. For rest, I'll leave it up to you to exercise it and try some more methods of it yourself. Um, so we have another important part left, which is to study how these are implemented. Actually implemented, I mean the hash set, tree set, and all the set implementation in a way like how the logic of hashing works in a hash set, how we can study that. So we'll be doing that and covering that in the next video, that is set part 3. Okay guys, so thank you as of now. Let's meet in the next tutorial. Thank you.